More of a societal question is, if AI can allow people to answer questions and do things in a job, are we going to see a downsizing in the qualification you need to do your job? In other words, at some point in time, a tech developer doesn't need to do 5 years or 10 years of training. They can actually code it off the internet. So you're actually just getting a human being inputting data rather than actually creating it or designing it themselves.
I mean, I must say, I don't actually think it's very useful to try to make these predictions, because I actually think we just don't know. There's some sort of comparison with the Industrial Revolution. So the Industrial Revolution happened, most people were in agriculture, and sometime later, something like 78% of people were in agriculture. Today, 2% of people are in agriculture. So there was a period of time where the people from the farms needed to move to the cities. They were disrupted. They lived in poverty, but they reskilled themselves, and they are farming no longer, right? So humanity survived it, but there's a whole bunch of people that suffered in the medium term. This is the same thing. I think the thing that is a little bit more worrying is that this is going to happen a lot faster. So we don't know what's going to happen, and there might be a whole bunch of people that loses their jobs, and we might stop knowing how to think properly because we don't need to write anymore. So there are all of those kind of fears, but humanity is incredibly robust as humanity to self-adjust and to create new jobs and create new things for people to do and to create new ways of operating. So I think there's going to be a lot of pain for a lot of people in the medium term, and hopefully that doesn't result in some societal upheaval that is sort of terminal for humanity. But at the end of it, we'll have humans that live very well with the machines and maybe work a lot less and have a lot more time for leisure and entertainment and all of those kind of things. My suggestion to you guys is it is going to happen. It's not something you can avoid. Adapt your businesses. Try to do what's going to happen in the next 6 months. To think too far ahead is very hard. It's my view.
Yeah, I've got a similar view. I just think that if you think of the construct of looking backwards, looking forwards, the issue of time, we're sitting today with models that have been trained that are becoming tools to us at an intellectual level that is purely looking backwards. So that means that it is attempting to find as many possible correlations as possible. So that means it's probabilistic to find out how you can use language as a pretty well-defined construct. Doesn't matter if it's a programming language or human spoken language. And the only way that we can look at this going forward, I think, is that you cannot stop looking at the tool. So I fully agree with Roger. I think that's going to happen. I mean, if I think about our business, it's been hugely important for us to do that because we wrote all our test scripts that were before done by teams. We now it's a single person that just knows what the concept is to do the work. It just means that the changing of work is what's happening. So the changing of work now means that if I know that I can use so many more people to become productive, and I can use what other people have done successfully, then that's fine. But if I want to get the next leading edge idea, it's not very likely that it's going to come from you just looking at tools all day. So we've been running some experiments internally to see if we could find, entirely new scientific methods, or because that one of the training data sources is like Google patents, the patent base. So if you have a patent base, can you get a language engine to predict something that's entirely novel from a combination of all of those? And what you probably will see quickly if you had to do this yourself is that probably 90% of what you do, somebody else has already done. When you're young, 99%. When you get older, probably 100% of what you've done, somebody else has done. And that means the only way you become successful is through this concept called error. And you need the error to happen for you to produce a new kind of data output. That new data output will be trained by the model and become available to other people. So that part, I think I've got a pretty firm prediction on. It's not going to stop. That means that your ability to use tools to become more productive is not going to slow down. So all that it's going to do, it's going to get you to hopefully fail faster, respond quicker, fix things, more rapidly. I'll give you an example. We're in the software business, right? So we don't use concepts like agile. For those who are in a software world will know what it means, because it's too slow. We do daily releases. You can't do 10 days, 20 days. Don't wait 6 weeks. We do daily updates. We've got daily releases, sometimes twice a day, depending on what's going on. Now you might want to ask, well, what changes twice a day? In actual fact, in the modeling world, we have got our real-time models change every 5-6 milliseconds. So that means that, but it's generated for us. The human influence for us has made us hugely more productive, because everything that was done before mechanically in the intellectual space is now done by a robot. The part that is still not automated, if you think about it for a moment, you can't go buy a robot to weed your garden, to mow your lawn successfully, to do some of the most basic physical things yet. And yet you can get the most complex creative activity output for free. So we see that part is the next area that's going to be tackled. So
just to add a bit to that. It's fascinating to think about competitive advantage. And I think for people in the room, that's quite a useful thing to think about. So if we talk about all of these AI things, it's an immense potential improvement in knowledge work and productivity and available to knowledge and availability just of data and all of those kind of things. Okay, so take that as a given. And it's fascinating that we sit in this room, and yesterday we talk about load shedding, and we talk about townships, and we talk about stuff that is insanely physical and geographically bound. So something that's quite fascinating to me is that sort of the concept of a geographic moat. Jay just talked about mowing your back lawn. That's a very, very small geographic moat. But we all operate in South Africa in a geographic moat. And our geographic moat is quite strong because we are actually here. Our market is too small for large other players to come here. So we're the only guys here that's willing to actually live here, right? So the competition is not that great. That's a geographic moat. Payment rails is a geographic moat. You can't just go and replace that with a large language model. So in terms of what your business models are, what are those moats? Which of those moats are geographical and physical? Can you make those stronger? Which of those geographical moats are going to be disappearing as a result of all of this productivity coming from other places and actually sort of increase your competition? But that's quite a sort of a fascinating thing for me to think about, is the productivity in terms of all of these tools, plus this physicality of what we do. And we are all in sort of fintech, which seems like not one of the most physical things that you can do, but it's actually fantastically physical. Like the pipes and the payment rails and all of those kind of things it's a very physical construct. Regulations and things around that, it's a very physical construct.
Yeah. Thanks. Yeah, I like that. So we use a phrase called hyperlocal.
Yes.
So if we know hyperlocal is when somebody wants to have an immediate experience. We're working with a big media company in the US now to try to predict itineraries when people move in a facility, and it's all about hyperlocality. When I stand in front of a restaurant or in front of a movie or theater or somewhere, and I'm going to influence that person, you have to know exactly what it smells like, what it feels like, what the sights are. You have to understand the hyperlocal situation, and you can't just go and use a language model to tell you what it is, because hyperlocal means that I'm physically present somewhere. So that means that understanding is, I think, going to be around for pretty much in the medium term.
Hi there, Roger. Hi there, Jay. Thank you very much for the talks. So I think both of you are quite are advocates of AI, as am I. Like, as we speak, we've got an AI bot on our website and all of that. But as technologists who are early adopters and maybe proponents, like crack dealers shoving ChatGPT down people's throats, how concerned are you about the alignment problem, maybe specifically in creating these solutions for businesses for your software? How worried are you about the alignment problem, and maybe just what that is for the audience?
I'll go first. Listen, we're very worried. I think that we've already had some situations under closed tests with the local, but with the US client.
Can you just explain what the alignment problem is?
So basically, the bigger problem is that if you have a specific contextual intent, if you think of classically when you had to engage with a human, humans naturally have an understanding of the contextual setting, so that means that we could quickly figure out if we're angry, if we're happy, if we've got a certain style of talking. Whatever we do is pretty much, humanistically wired into us genetically. So we already come with that pre-trained model when we grow up, right? And if you don't have it, society will then maybe put you somewhere else. They'll put you in a facility or something if you don't have the same genetic wiring as the rest of the people around you. That's kind of how we are socially organized. So in a language model world, in a classical bot world, you could give it a decisioning tree and you can force it to say, well, if it gets to a point, I don't know what you're talking about. That means that it's simple. You can just stop it there and you have a very discrete boundary that you can work towards. In the language models, the one we're working on now, is that imagine that I am, let's say, in a hotel and I'm searching for a restaurant. Would I realistically want the itinerary that comes back to recommend a restaurant from a competing hotel? Or would I want it to recommend a restaurant from the hotel across the road, or the restaurant that's 4 floors up? Or should it recommend a restaurant on, the sky deck, whatever you want to call it, or the one that's right in front of me because I'm standing right in front of it? So does it need to understand? So for us, we see the alignment problem is that whole way in which you contextually align the language, what the person's intent is, how they do what they need to do. It is a massive challenge in the new language world, because you think the bot's just going to give you answers, but if you want to make it relevant for that moment, it's far more problematic. So that means that the software tooling now means that if you're going to fine-tune a model, that's the language, by the way. The language is called fine-tuning a language model, so you can build your own data sets. It's too costly. So that means that can you take a base model, tell it to not hallucinate, and find prompt injection and prompt engineering that fits with fact injection. And in our case, we've got a framework that we work with clients on that's been implemented like that. But it's still in test mode because we're not confident that we can stop the model from lying. Or stop the model even though we've, specifically affected the embeddings to stop doing certain things, you can still see that sometimes it goes out there and gives something that it's not supposed to.
I think if your intent is good, we talk about prompt engineering, but basically prompt is like the recent memory that you give to the chatbot, and that memory is perfect. Like it will work off that memory and it'll give you answers of that memory, and there's no alignment problems in there unless your base documentation has got an alignment problem, and it'll do what you need it to do. And these models are extremely public, so a lot of the effort that goes into ChatGPT makes sure that it's truthful, that it's not offensive, any of those kind of things. There's a lot of those other sort of toddlers that's running around that's extremely offensive, and that's got, if they train on the dark web and those kind of things, they'll be really badass kids. So, but ChatGPT for now it's probably fine. Yeah. And I mean, you guys should also understand the risks. There are ways in which you use ChatGPT, and then the language or the prompting that you put in becomes public knowledge. It becomes part of that big base of knowledge. There's been some examples of people that's actually taken company documents, and suddenly ChatGPT now knows what your company does and will answer other people on your company documents. It's not the biggest issue for most people, but there are risks in these things, as there are with any tools.
Now that's the concept is we use adversarial models. So you train it on all the things that it's not supposed to do. Humans naturally grow up. When you do something when you're a kid that's wrong, you slap on a wrist or something, or a parent will say no, or you'll be reprimanded at school or something, and that kind of programs you over time. And the problem with the training architectures of the large language models or anything in a deep learning world is that it's got no proper forgetfulness function. It is mostly focusing on training, making an assumption that everything it's trained on is perfect. So in our world, we're always trying to find what we call the sensation of difference. That's kind of one of the core parts of our offering, is that can you find the parts that I know that it definitely must not do? So if I train it on all the things that is wrong, I can then get the model that is supposed to give me the right answer to never even tread anywhere within that space. So there are adversarial models, as they are called, adversarial practices that you can use to do that. So it's used in self-drive cars and so on as well. So we've been trying to understand, can you take practices from like devices, like cars and so on, and apply it to human behavior? And it's been pretty effective so far. So I think that's maybe we'll definitely look at that if you're interested. Yeah.
And then, sorry, the other thing is what you guys should strongly do is avoid the news. Like these models are going to be held to an extremely high standard. I mean, that example that Colin just gave, it's an actual example out of Snapchat. It is just an example. That thing is going to get it right most of the time. It's like, do you want to be on the road with a whole bunch of Teslas in self-driving mode as opposed to a whole bunch of drunk people that just came from the rugby? Tesla every day of the week. But Tesla makes one accident, and it's all over the news. Right, so these models are going to be spectacular. They're going to work extremely well. They're going to get it wrong sometimes, and if they get it wrong, it's going to be all over the news, and it's going to seem a lot worse than it is. I think we're going to be okay.
Who's next?
Cool. So since the 50s, I think we've had ups and downs of AI activity and then moments of less activity, and they've been referred to as AI winters. Can we not expect a similar cycle, and what would that be that would, or do we consider this to be the breakout moment? And
It feels like it.
Because at the end of the day, these AIs, it's not an AGI, it's not a general intelligence, it's really just a sophisticated probability distribution.
Close. Sure.
But isn't that the limitation itself, that it's just a statistical distribution?
It's a valid question, but what's the relevance of the answer? The stuff that the stuff does now is magical. It is absolutely incredible, the stuff you can get out of it. That's not going to change. And if it's just that for the next 20 years, then that's fantastic. Let's use it. Whether it's going to be able to now string things together and not have a one-track mind and those kind of things, I don't know. It's fascinating to think about.
But I think that the cost of computation, cost of storage, we know that already. If you go look at the flops, so the floating point operations, per second at the moment that is support, you know that it's basically gone up 100 times in the last 3 years. So that means that the access to computation is what the last winter was all about. We might go into a winter concept if you think of what happened in the 80s. I got exposed to AI first time in 87, my postgrad started. And it was, impossible to train a model. And actually, in fact, if you had to do a linear regression, you would, run it on, I don't know, if you had a meg of memory, it was a lot. So if you think about it now, it's an entirely different world. So the 80s, that blockage, I think, is gone. I think the era we're moving into now is the master algorithm. So go look at Domingos' work. I don't know if you follow his work at all. He published a public book that is quite readable. It's basically talking about the tribes of AI. It's called the master algorithm. And the concept is saying that we are at the moment in an algorithm drought. Even though with a large language, generative models have been around for a while. The current architecture makes an assumption that the human brain or the neural style network is the only way that you can see intelligence. The problem with intelligence is that true intelligence can't see the intelligence that made it at all, or that intelligence that it observes but doesn't understand it. It cannot theorize it. So at the moment, there's a big movement. And actually, in fact, University of Washington in Seattle is running a big program. We're busy with them at the moment trying to see if we can get some input there. But they're trying to come up with a new architecture to say, well, is there a new way in which you can encode intelligence that includes the forgetfulness capability that humans by default can do? You can forget about bad events. And actually, you can program yourself to get over trauma, or you cannot. Some do, some don't. So that means there's a way in which humans naturally deal with things that we don't have an architecture for in AI at the moment. So I think that is the era we're moving into now. Now that we've got the computation and the data and everything ready, now we need to invent new algorithms. And that's what you see what's happening at the moment, especially with the large language models, because they're attempting new architectures on old ideas. And we get novel results that create incredible tools by taking tiny tweaks on the existing architecture. Imagine we come up with an entirely new architecture for learning. Anyway, that's...
If you go back 1,000 years, maybe even before that, and you took the sort of hunter-gatherer stage. Like if you take what hunter-gatherers did now, and like 500 years later, it's very little change. I mean, they might have had a little bit of innovations and some tools that came out, but it took extremely long for things to change. If you go back to the previous century, sort of every 10-year gap, there's been changes, and the sort of the rate of possible futures start expanding. Feels to me, certainly, like literally in the last 5 months, the possible futures have just like exploded. Like the change that is ahead of us is massive. You don't know what it is. Very, very difficult to predict. That's why I think it's interesting to talk about what's going to happen. It's very hard.
Roger, from an AI kind of fund perspective, what are the short-term use cases that you're focusing on from an investment thesis perspective with what's changed and the acceleration of what's now possible in the short term?
So up until last year, our sort of investment thesis was find companies that can use algorithms and best case sort of machine learning, plus using data to make data-driven decisions. And I really liked Jay's example of the car, where you sit in the car and you've got things and then the human decides. Like the human's got real-time information. So our business is very much human-machine, great tooling, see what's happening, great dashboards. And in some instances, you'll have algorithms running in the background and doing things automatically. As of now, I don't know. It's this thing has changed things quite a bit, and it's disconcerting, because it's disconcerting if business models are going to change. What I'm quite fearful of is that that this sort of removes barriers. Like there's businesses that can come into your space. I mean, we very strongly only invest in tool users, not tool builders. I think one of the dangers for tool builders is they're dancing with elephants. Like you've got Meta and Google and these guys, and if they step sideways and sort of suddenly build a tool that you've been taking all your family and friends' money and investing in it, and they suddenly make it for free and it's a lot better than yours, and your business is dead. So in our portfolio companies, we're having these kinds of conversations. What are we doing with these tools? Can we get some use cases up and running? Just start. Like even if it's hack jobs, like find places to put it in, because we'll learn. And we do have a few companies that's using it very successfully. Marketing, communication. I'm not skilled enough to really see whether they're doing it on the coding side, but there's lots of conversations on the coding side, and I think the coding guys are quite into it. I'm hoping we find a few companies that use it really well, or that our companies use it well, and they become more productive. But I think in the short term, it's an immense productivity tool. You don't want to miss that. I don't know, but I don't know is what the business model changes are going to be.
I can give you a glimpse of San Francisco for people we've spoken to. It's almost expected that you'll have a dualistic business model. So in our case, our enterprise clients use the tooling, but that's, as you know, no feature for there. You're in what's called the mushy middle. Mushy middle means that you sit with the platform squeezing up and a client squeezing down. So that means that the dualistic model, if you think of OpenAI, charging you $20 a month for the chat service, and that means that turning prediction as a service into a business model. So I mean, we've got a bunch of clients that we brought online in a dualistic model, where their job is not, they don't buy the tools or anything like that. They use it to make money. And that means that you only make money on the upswing. So how do you know that a human algorithm works, is implemented, get the upswing, track it on your control group initially, and then expand it across your base? So we definitely see that, and actually everybody that I talk to that's in our space have got dualistic models. So the tool companies, the handful that are there, purely prepare their businesses to sell. And listen, I don't like that style. We deeply engage with our clients because all our stuff is value-based. So it's value-based. Like we got a big client, telco clients in Africa. So we work with a couple, and I can tell you, I mean, we affect 100 million people's lives daily. And if it's not there, the only way that you know that it's working, the CEO sits with the dashboard in the office. Every day you look at about 80, we've got 80 plus cases in production. You track the top 20. How do you know that it's making money? You turn it off. and you watch the drop around that offer, that segment, that geography. So we do geographical, you shut it off. And you go back to the old way, just selling what you had. The gap between that turning off of that is the value. Okay, we can keep you on. So we kind of think that that is, at least what I'm seeing in the medium term. In the US, everybody we talk to wants that. They don't want to buy license fees, product stuff, because, Microsoft and the like, and especially look at them buying OpenAI now, are running to all their clients telling them they're going to solve all of the world's problems with deep learning until you get them to do the job, and you're going to find you're not going to have a case live in a year. So there's definitely that gap between the story and the implementation, and the people who can implement, most of them would want to share in the upswing if they know it's going to make a difference, not just say, well, yeah, pay me a fee. Yeah. So this is our view. It's quite narrow, obviously. But
So I think the good news for all of you is that you guys have got the skills to do this, because I think for everybody in this room who are basically business leaders, the skill that you need is organizational design. You need to apply your organizational design skills. You don't need to know how to code. You don't need to know how the AI works. What you need to know is how to configure your organization. And there's a few directional bets that you can make. Like client service is going to become hugely impacted by this, and it's going to become a lot cheaper. So if that's the case, go and invest in people inside your organization that drives that finds new places to implement those things every day of the week. And they don't need to be that skilled in doing it. Like the tools are going to change so fast that even if you find a guy that's really good with it now, the skills are going to be different tomorrow. And the success that you're going to get is by your organizational design, your innovation in your organizational design. The tools are going to come and go like there's no tomorrow. Your core business problems that you're trying to solve are largely going to still stay intact. The ways in which they're going to be solved is going to be different. Just organizational design is, I think, everything.
And I think what's happened already with the GPT-3 versus 4 and 4.038, the new release now, and GPT-5 is going to be different again, is the prompts change entirely. So whatever worked in 3, so what happened in the 3 architecture was that the way that the generative piece of the model worked in its output layer is that you had to really be quite specific to tell it in a latent space which patterns to use. So that means that you had to give the prompt a lot of detail. Now what happened in 4, they solved a lot of that. Because of the feedback from 3's usage, means that in 4, you can literally get away with 4 words and do the same as that you had before with about 5, 6 to 10 lines of content. So now you've got the system prompts and so on that can tell the engine to behave in a certain context with a certain profession. So that means that the people who get involved in this, you want them, and I think you mentioned it earlier, reading the documentation, you have to do that. Because the models are so different. I mean, OpenAI has got a model called the Curry model and the Ada model and a couple other models that are far better than the main OpenAI or the main GPT-3 or 4 models for certain applications. But it's a lot cheaper. So that means that computational cost understanding, it becomes a business problem. I don't see that, I mean, even us, we only train a tiny portion of our portfolio is us doing the neural net. We influence the model by adding embeddings and other things into it. There is still a technical specialization, but I can definitely not say we differentiate on that. Because it's a skill that anybody can acquire, and actually you can ask GPT how to do that. And it's pretty good at telling you how to create an embedding for itself. But the business problem that you're solving with all of the surrounding issues, and actually our real-time engine success that we have in our real-time engagements, is not even the prediction necessarily. It's the fact that it can do real-time logging, feedback, real-time. We've got Q-learning algorithm that's by far the most efficient in computation for telcos.
Jay.
Yeah.
Right, enough. So, last question coming through from Paul, otherwise we're not going to hit the deadline.
Gentlemen, thanks. Privileged to listen to your talks, and your expertise is amazing. Are we witnessing the end of Moore's Law? I mean, we all grew up with it, and we're approaching the physical limits. And now with the NVIDIA chips, I'm hearing that they're potentially 1,000 times more powerful. Do we see this as the demise of the old linear CPU in time?
Short answers, please. Jay.
Well, quantum computing is happening. Embedded AI systems are there, so that's not going to stop. And we're far more interested in Metcalfe's law than Moore's law as a business. So Metcalfe's law is a law that says that every node that you add to a network makes it, basically gradually more useful. So it's not quite exponential the way that Moore outlined Moore's law as you know it. But what it means for us is that if I can influence a cluster of people or a cluster of group, that means that the adoption rate is not about adoption anymore. It's about absorptive capacity. So I think that there's huge activity in that space at the moment in our community, and especially in the Palo Alto region. Companies trying to use AI to drive human absorptive capacity. So how do you get a human to stop doing what they're doing and start using what you have now that's novel? And I think that's still pretty much exponential, the same as the computing is still. So I'm not sure that quantum is the next phase. We're waiting, so we'll see. But yeah, maybe that's short answers.
There's an absolutely fascinating book called Chip Wars, which I highly recommend. And that talks about how Moore's law, all the physics behind that and so on. And according to that book, we are reaching sort of atomic sort of ceilings in terms of Moore's law. But then there's all kinds of new designs and things like that that makes Moore's law, in a strange way, slightly less relevant, because you just like string lots of computers together and you've got all of these systems and things that's in place. But just understanding the whole China, Taiwan, US conflict and how that's driven by sort of chip manufacturing and the dependencies on chips and decisions that's made. And I think for everybody in the room as well, the change in business models and the bets that you make. I mean, the fact that you've got NVIDIA now and in a day's jump in market cap, it's the entire Intel. I mean, Intel like ruled the world 20 years ago in terms of Intel inside everything. And they just made decisions in their business models and the way that they were risk averse. And by being risk averse, that was actually the most risky thing that they could ever do. Like really, you need to adapt and change. To be risk averse is probably the most risky thing you can do.
No, that's Andy Grove's Only the Paranoid Survive.
Yeah.
And then they got into the same trap some years later. That's a great book as well, by the way. The guy who turned Intel around in it was early 90s, I think, or late 80s. He basically turned it from a memory chip business into a CPU business. And he created this thing called Only the Paranoid Survive. And how do you know your inflection point? The point at which you need to stop doing what is making you profitable at this point and do the opposite. Anyway, it's fascinating.
Guys, Jay, Roger, thank you very much. Round of applause, everyone.